Hello, fifth graders. Glad to have you here again as we continue our exploration of symmetry. So yesterday we talked about line symmetry, and you learned that if a line divides something perfectly in half so the two sides are equal and reflections of each other, that's a line of symmetry. One thing that the IXL didn't cover is that sometimes you have to count how many lines of symmetry a shape has. I see one line of symmetry that I drew on there. How many more do you see? I trust you all saw that line of symmetry. You can always test it if you're not sure. If you fold it on that line, it's symmetrical if the two sides match up like this. So clearly that was a line of symmetry. Question for you. Is this a line of symmetry? And clearly if that's a line of symmetry, then this too would be a line of symmetry. This is harder than it looks. So do you think that there are 1, 2, 3, 4 lines of symmetry? We can check if this is a line of symmetry by folding it. As you see, when we fold it, the sides all match up. So yes, those are all lines of symmetry. Okay? How about a rectangle? Okay? I know you all know that that's going to be a line of symmetry. And of course, this is going to be a line of symmetry. But I guess my next question is this a line of symmetry in a rectangle? A lot of students say yes to that, but you'll see that if you try to fold it along that line, I didn't fold it really well, but you get the gist. The sides are not going to match up. So a rectangle only has 2 lines of symmetry, whereas a square has 4 lines of symmetry. But today, we're talking about rotational symmetry. And this is the first word that you need to define today is rotational symmetry. So in your vocabulary notebook, you're going to want to write this down. A figure has rotational symmetry if you can rotate, turn it, and have it look the same as when you started. And a star there I have less than 360 degrees, which I'll explain in just a second. So go ahead and pause it while you copy that down, and then you can restart. Okay, so what they're talking about, let's go back to our square here. Okay, we have our square that looks like this. If we can turn it, and it turns out to be in the same orientation, then it has rotational symmetry. Hey, we did it. So it has rotational symmetry. In fact, you could do it in 1, 2, 3. It's called a fourth order, but you don't need to know that. It's just that there's a bunch of different places you can have rotational symmetry. Okay? With our rectangle, when it starts like this, so there's our rectangle. Now if I turn it 90 degrees, no rotational symmetry. But if I turn it 180 degrees, it has rotational symmetry. So yes, a rectangle has rotational symmetry, but only 2 places instead of 4 like the square. Okay, so I guess my next question will be, well, before I even ask the question, let's look at something like this. Does it have rotational symmetry? Now, any object in the world, if you turn it all the way around back to where it started from, it's going to look the same. That does not count as rotational symmetry. It has to have rotational symmetry somewhere along the way. So if I start turning this, is there a place where it looks like it's in the exact same orientation as the first one? And there isn't until it gets all the way back to the beginning. So that does not have rotational symmetry. What do you think about this one? Will it have rotational symmetry? Let me try to record its beginning place. And you can see if I turn it just a little bit, not quite. If I turn it all the way to there, yes it does. So there's 1, 2, 3, 4, 5, and then back to the beginning 6 places where it has rotational symmetry. Okay. All right, let's try a little trickier one. Does this have rotational symmetry? We start it like this. And I'll trace along the side like that so you know what the original orientation was like. All right. All right, so if I turn it, no, 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 no. Yes, so it has rotational symmetry because it started here, and when I went 180 degrees, it was back to its original orientation. What do you think about this one? Will it have rotational symmetry? Take your guess. All right, so let's put another one right on top of it. And if I start twisting it, that's 90 degrees. That's 180. As you can see, it's not exactly the same because this loop is smaller than the other loop. So you have to take it all the way back to the beginning before it matches up, so that means it does not have rotational symmetry. Okay, last one of the day. Does this have rotational symmetry? Well, you see if you turn it 90 degrees, definitely not. If you turn it like this, no, it doesn't, because now the prongs are on the other opposite side, and the small gold side is on this side, so it does not have rotational symmetry. Okay. All right, that's all you have to do today on the IXL, and good luck.